Hello students, let us start with physics topic 11, scalars and vectors. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Define scalars. Scalar quantities have only magnitude. For example, mass, temperature, distance, speed, time, power, energy, etc. All these quantities are scalar quantities as they do not have any direction associated with them. Scalar quantities change when their magnitude changes. Such quantities can be added or subtracted using the law of simple algebra. For example, 11 meter, 15 meter per second, both are scalar quantities. Some important points. It obeys simple laws of algebra. The scalar quantity which is found by modulus of vector quantity is always positive. Example, distance, speed, etc. The scalar quantity which is found by dot product of two vectors may be negative. Example, work, power, etc. The tensor rank of scalar quantity is 0. Define vectors. Vectors are physical quantities which have both magnitude and directions and obeys triangle law or parallelogram law of addition. Some of the vector quantities are displacement, velocity, acceleration, momentum, force, weight, etc. Vector quantities change when their magnitude changes, their direction changes, their magnitude and direction both changes. The difference in two vector quantities is equal to final vector minus initial vector. Example, a geostationary satellite is in orbit above the Earth. It moves at constant speed, but its velocity is constantly changing, since its direction is always changing. Weather station measures temperature. It is scalar quantity that can be positive or negative, say plus 20 degrees centigrade, minus 5 degrees centigrade, but has no direction. It also measures wind velocity, which is a vector quantity with both magnitude and direction. For example, 15 km per hour from the west. The difference in two scalar quantity is equal to large value minus small value. Let me explain the vector quantity taking displacement as an example. A. We represent a displacement by an arrow pointing in the direction of the displacement. In the below figure, starting point is P1, ending point is P2, displacement is A. B. Displacement depends on the starting and ending position, not on the path taken. In the below figure, path taken is long, but displacement is the shortest distance between P1 and P2. C. Total displacement for a round trip is zero, regardless of the distance traveled. In the below figure, we can see the displacement is zero. Equality of vectors. Two vectors representing two values of the same physical quantity are called equal if their magnitude and directions are same. For example, in the below figure, A and B are equal vectors. Addition of vectors, graphical method. First, triangular or triangle rule of vector. If A and B are two vectors to be added, in which the tail of B coincides with the head of A, the vector joining the tail of A with the head of B is the vector sum of A and B. So in the below figure, C is equal to A plus B. Parallelogram rule of vector. If A and B are two vectors to be added in which both the tails coincides, taking these two as adjacent side, we complete the parallelogram. The diagonal through the common tail gives the sum of two vectors. Therefore, in the below figure, C is equal to A plus B. Sum of two parallel and antiparallel vectors. The sum of two parallel vectors are explained below. A is a vector, B is another vector in the same direction. Therefore, C is equal to A plus B. The sum of two antiparallel vectors are explained below. A is a vector, C is equal to A plus B, B is a vector with opposite sign. Different scenarios to find out the sum of three vectors A plus B plus C. Scenario 1. We could add A and B to get D and then add C to D to get the final sum R. Scenario 2. We could add B and C to get E and then add A to E to get the final sum R. Scenario 3. We could add A, B and C to get R. Scenario 4. We could add A, B and C to any order to get the final sum R. Subtraction of vector, graphical method. Subtracting B from A. Method 1. Add minus B to A. Method 2. With A and minus B, head to tail, A minus B is a vector from the tail of A to the head of minus B. Method 3. With A and B head to head, A minus B is the vector from the tail of A to the tail of B. Multiplying a vector with scalar. Multiplying a vector with a positive scalar. Multiplying a vector by a positive scalar changes the magnitude, length of the vector, but not its direction. For example, A is a vector, 2A is another vector with twice as long as A. B. Multiplying a vector with a negative scalar. Multiplying a vector by a negative scalar changes its magnitude and reverses its direction. For example, A and 3A has a different direction. Therefore, we have written minus 3A. Minus 3A is 3 times as long as A and points in the opposite direction. Null or zero vector. If a vector is subtracted from itself, then the resultant is a zero vector or null vector. A null vector has a zero magnitude and its direction cannot be specified. Therefore, A plus minus A is equal to 0. Properties of null vector. A plus 0 is equal to A. N into multiplied by 0 is equal to 0. 0 multiplied by A is equal to 0. And modulus of 0 is equal to 0. Unit vector. A vector having unit magnitude and pointing in a perpendicular direction is called a unit vector. It has no unit and dimension. It is only used to specify a direction. A unit vector corresponding to a vector A is represented by unit vector A. Unit vector A is equal to vector A upon A. Vectors parallel to x-axis, y-axis and z-axis can be represented as below. X is equal to modulus of x into I, y is equal to modulus of y into z, z is equal to modulus of z into k. Here I, j, k are the unit vectors along the coordinates axis x, y and z respectively. Rectangular components. Let A be in xy plane making an angle theta with x-axis. We can represent any vector lying in the xy plane as a sum of vector parallel to the x-axis and a vector parallel to y-axis. These two vectors are labeled ax and ay. Then they are called the components of vector A and their vector sum is equal to A is equal to ax plus ay. In the given figure, ax is equal to a cos theta, ay is equal to a sin theta. Dividing equation 2 by equation 1, we get theta is equal to tan inverse ay by ax. Laws of cosines. Laws of cosine. Suppose the magnitude of vector A is equal to A and vector B is equal to B. Suppose the angle between A and B is theta. Therefore, from the given figure, applying Pythagoras theorem, we get AD square is equal to AB plus BE square plus DE square. Instead of AB, we can write A. Instead of BE, we can write component of B, that is B cos theta. And instead of DE, we can write B sin theta. Therefore, now the equation became A plus B cos theta whole square plus B sin theta square. After resolving this equation, we get A square plus 2AB cos theta plus B square. Thus, the magnitude of A and B is under root a square plus b square plus 2ab cos theta. This is known as law of cosines. Its angle with A is alpha, where tan alpha is equal to DE upon AE is equal to B sin theta upon A plus B cos theta. And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.